Hello class. This lesson we're going to learn about vectors and translations. To start us off, here's a refresher on the word parallel. Now it's important that you say that the lines are on the same plane. If you have two lines on different planes and they don't cross, those are called skew lines. So we're going to do a construction where we construct parallel lines. So we want to make a line parallel to line AB that goes through point P. First step is to measure distance AB. That's going to be the radius of a circle centered at P. Now this is very similar to when we were copying an angle. Remember we centered the pivot on the angle we were copying and we drew a circle. And then we drew the circle on the new vertex. Same idea here. Now we want to measure from A to P. So this is kind of like when we were measuring between the points of intersection on the angle we were copying. Same idea here. And now we want to put it at B and draw a circle. And so it's not exactly the same as copying an angle construction, but when we do this, we actually will have angles that are congruent. And so we call this point over here Q. And there's 2 points we could have picked, but we picked this one on the right because if we had picked the point on the left, we'd end up with a line that is not parallel, that would go through the first line. And one way you can tell is you want to pick it so that A and Q are on opposite sides of line PB. So A and Q are on different sides. So now if we connect P and Q, we will have a parallel line. So why does this work? Well, remember I said this was very similar to the construction we did when we were copying an angle. And it turns out that angle ABP, so let's draw a transversal in there, is congruent to angle QPB by these steps. And so those are alternate interior angles. So when those are congruent, the lines are parallel. So this takes us to our definition of a translation. So translation notation, it's a capital T for the function, and the only parameter is the vector that you're translating along. And so the definition, this diagram is a little bit different than the one we started with, but we're going to use it to describe what's going on. Any points that is on the line that the vector is in is going to just get moved. So for example, here's our vector, starts at A and goes to B. And say I wanted to translate this point. All I would do is just pick this point at the end of that vector. So just move it that same distance. Now that's not that interesting. Let's look at the second part. What about points that aren't on that same line? So any point that's not on it, you follow these steps. And we're going to get to the definition of a vector again. But remember, it has a magnitude or distance and a direction. And that's what this definition is saying. The first part says you want to have a line that's parallel to the point that you're moving. I'm sorry, that goes through the point you're moving and parallel to the line that the vector is in. So this line L. This describes the direction. We know that AB goes a little bit up and to the right. And so line L is parallel, so that's going to have that same slope. And M is going to describe the distance. M is going to be going to pass through B, so the end of the vector, and parallel to line AP. So this is saying how far are you moving, this red line here. So this process really is describing what we have in a vector. And so we can use that parallel line construction to do translations. And once again, it's basic rigid motion. So the segments don't change in size and the angle measurements stay the same. So here's a definition of a vector. Remember, it looks like a ray, but it's really not. You're going to know from the context if it's a ray or not. It's a directed line segment, so it has a finite length and it has a direction as well. So for example, we have this quadrilateral, ABCD, and it's been translated along vector C, C prime. I want you to note that you can draw a vector anywhere in the diagram and it's still equivalent to the original vector. So we could have drawn this vector over at B and it's still the same. Points is at B prime. You could draw it at D or you could draw it at A. So that's a special property of vectors. No matter where you draw it on the plane, it's correct because all you want is the distance and the direction. It doesn't matter where it is. So why don't you practice drawing vectors for each of the diagrams here? The pre-image is the solid one, and the image is the one with the dashed lines. So try that, and I'll show you my solutions. So here's my first one. Now, just because you don't have the vector I drew doesn't mean you did it incorrectly. You could have drawn this in many other locations. You could have drawn this vector over here, down here, this corner, or you could really have picked any pair of corresponding points, but you usually want to stick to vertices because that's very clear what you're pointing at. So usually try to stay away from just being in the middle of the side. Try to stick with the vertex if you can. Over here, be careful with the direction. The vector should be pointing towards the left. And once again, you could have put it in lots of other places and still have the correct answer. And finally, you can draw the vector on top of the figure. That's okay. So here's one vector. You could have drawn it over here. Right? It doesn't matter. It's still the same distance and direction. So let's actually do a translation. So we want to translate segment P1, P2 using vector AB. So to do that, remember we have to get the distance and the direction. So to get the distance, you're going to measure from A to B. And now you're going to draw a circle around point P1. So we know that the point that we get after the translation, the image, is going to be on the circle somewhere. So now we just got to figure out, well, where on it? So to do that, you're going to measure from A to P. This is where we get the direction part from. I'm sorry, from A to P1. And you're not going to draw anything just yet. You're going to move the pivot along the vector to the very end, and now you're going to draw your circle. And so make sure you pick the correct point. So here's, I named it Q1. Sometimes if we're using subscripts, you don't really want to use the prime notation because then you have subscripts and apostrophes and it looks kind of messy. So let's call it Q1. Now, remember if you'd pick this one, that would be going the wrong direction. Your vector would be pointing down to the right. You don't want that. We're going to repeat these steps with P2. So I'm going to delete these first circles and go through the steps again. So once again, measure AB. And then put the pivot on P2. This is giving us the distance of our vector. And now we need the direction of our vector. So put the pivot on A and measure to P2. And so now we want the direction, so you're going to move to the end of the vector at B and draw a circle. Not like that. And now we pick the point where we have the vector going in the correct direction, so this point. And now, if we connect Q1 and Q2, we will have a segment that has been translated along vector AB. There we go. So, sometimes though, you're going to be translating on the coordinate plane. And when you're doing that, you actually don't need the compass at all. You can just do it just by moving points around. So on this one, we have the coordinates of triangle ABC. So why don't you take a moment to graph that on a piece of paper and see if you can do the translation. And I'm going to show you how I do it in just a moment. So try that and then come back. So here is my triangle ABC. Looks a little bit off. Okay, here's triangle ABC. I had my grid was a little bit off, sorry. So I want to translate 4 units to the left and 2 units down. So for every point, I'm going to go 1, 2, 3, 4, and down 2. Left 1, 2, 3, 4, down 2. 1, 2, 3, 4, down, oops, down 2. So here is the image, triangle A prime, B prime, C prime. And now we want to draw a vector that defines it. So pick a pair of corresponding points and draw your vector in there. And make sure you have the arrow. Without the arrow, you don't know which way your vector is going. And so you could have drawn it there, you could have drawn it at A or B. Like I said, there's other points, but those are going to be the 3 most common ones for this vector. Okay, in this lesson we learned how to do translations and we learned how to draw vectors that describe them. Thanks for watching this video.